Welcome to Algebra 2, Unit 7, Lesson 10, Practice Problems. This lesson has one vocabulary term, which is margin of error. The margin of error is the maximum expected difference between an estimate for a population characteristic and the actual value of the population characteristic. Meaning, how big a difference is there to the high side and the low side of what we think the mean is? How much of an error could there be? If I report a result, how much higher than that result could the actual result be, and how much lower than that reported result could the actual result be? If you have any questions about the concept of margin of error, please ask for clarification so that you are set up for success moving into these practice problems. A scientist captures a sample of fish from 100 different locations along the Yellowstone River and measures the proportion of fish affected by copper toxicity for each sample. Describe how the scientist could use the data to estimate the proportion of fish affected by copper toxicity in the entire population along this portion of the river. So, the scientist should find the mean and standard deviation of the sample population. Then multiply the standard deviation by 2 to find the margin of error. Then apply this range to the entire population. Remember that for margin of error, we want 95%, which means we want 2 standard deviations above the mean and 2 standard deviations below the mean. Once we find that for the sample population, we can apply that to the entire population. If you have any questions about how the standard deviation and the margin of error relate to each other, or how we can use data from sample populations and apply it to entire populations, please ask for clarification so that you are set up for success moving forward onto the next practice problem. A company produces 1,000 blue crayons every day. A sample of 50 crayons are analyzed, and 3 of them are found to not meet the standards of the company, so they are labeled defective. A simulation is run in which 50 crayons are chosen out of 1,000 so that each crayon chosen has a 6% chance of being defective. The simulation is run 500 times, and the mean proportion of defective crayons is 0.059, which is a standard deviation of 0.012. What is a good margin of error based on this simulation? If I want margin of error, I am going to take the standard deviation and multiply it by 2. So 2 times 0.012 equals 0.024 margin of error. Number 2, based on a population proportion estimate and margin of error, is 0.07 a plausible value for the population proportion of crayons that are defective? Explain your reasoning. So we need to take the mean proportion of defective crayons, and we need to add the margin of error and subtract the margin of error. So 0.059 minus 0.024 equals 0.035. This is the low end. Then we need to take 0.059 and add the margin of error. And this equals 0.083. This is the high end. So 0.07 is in this range. So yes, it is plausible because 0.07 is in the range between 0.035 and 0.083. If you have any questions about how to determine the margin of error and how to apply the margin of error to the mean in order to find the plausible range of results, please ask for clarification so that you can be set up for success moving on to the next practice problem. Our last practice problem for lesson 10 says a researcher uses a random sample of 200 people in prison in the United States to find that the proportion of the prison population that is jailed for drug-related crimes is 0.485. The researcher simulates selecting a sample of 200 prisoners, each with a 48.5% chance of being in prison for drug-related crimes. The simulation is run 400 times and the results are shown in the histogram. Use the histogram and information from the original sample to estimate the proportion of prisoners in the United States that is in prison for drug-related crimes. Be sure to include a margin of error with your estimate. So, the proportion was 0.485. The margin of error should be 2 standard deviations so that we get 95% of all results. So 400 simulations times 95% equals 380 results. So I want a large enough margin of error to get 380 results. Well, if you look, this bar down here looks to be about 10. And this bar on the other end also appears to be 10. And if we say that the proportion is 0.485, then it appears 2 standard deviations to the right would be 0.56 minus 0.48.5. So this would be about 0.075. In the other direction, we're looking at 0.42. So this would be about 0.065. So I'm going to meet in the middle, 0.075 plus 0.065 divided by 2 equals 0.07. So I estimate the margin of error to be about 0.07. So now we would be looking at a range anywhere from 0.415 to 0.555. So 41.5% to 55.5% in prison for drug-related crimes. If you have any questions about how to determine proportion or margin of error using a histogram, please ask for clarification so that you are set up for success as we move on to Lesson 11 and eventually on to your end of Unit 7 test.